In today's episode of Factory of the Future podcast, we're going to be interviewing Richard Halsall. And it's going to go in a couple of different ways. One thing, Richard is an inventor, founder, and CEO of the Excel Fan. And what drives us in the interest of Factory in the Future is his innovative and changing ways of how ceiling fans can deliver bladeless airflow, which also reduces energy consumption, which in Factory of the Future is something that we're always trying to understand a little bit more. And we also go into a little bit about, what is it like to be an inventor that takes something from the start to the assembly line, to production, to the stores. And he's going to share a little bit about his journey on that. In addition to how he took what was a assembly and why he took assemblies overseas from the U.S. headquarters where it's currently located. He also shares a little bit about some of the stories of his journeys throughout the way through his invention and what has driven him for that. So who is Richard? Well, Richard serves as the founder and CEO and as I said, the inventor of the Excel Fan. The creating was one of the most efficient HVAC delivery systems, produces the world's only bladeless ceiling fan, designed to support energy efficient needs for most any kind of building you can think of, offices, hotels, airports, etc. The technology that was the inventor that Richard brought toward has been tested at Purdue universities, which produces an air circulation throughout an entire room. So when you think about a ceiling fan blowing straight on you, this one rotates and changes a little bit differently. And he's going to find out what Richard has had a lifelong career of dealing with air circulation and airflow. In 2017, he was fully immersed himself as a young company and pivoted to a large-scale production, which granted him the opportunity to introduce critical new features that are now part of the flagship model that he calls the EF34 Excel Fan. What's more, it was under the guidance that changed to all phases of the business operation. So translating it from the beginning to what was the fourth generation of the EF34, which debuted, I got it, in 2018. Most recently, he's been working on the next generation, which is debuting right now. Not only does it offer bladeless technology, but it also reduces energy consumption, which is around 10% reduction in HVAC energy cost. So as I said, he deals well with airflow. Prior to founding Excel Fans, Richard served in the U.S. Army on the Halo Cobra pilot, those helicopters with all the armor on it, in Vietnam, as well as a pilot for a major U.S. airlines, which he retired in 2015. So with all that said, let's bring Richard on and listen to the show.
Welcome to Factory of the Future, People-Powered Health. Podcast focused on trends shaping the future of manufacturing. I'm Alexandria Burek, your host, here with A.W. Schultz, two thought leaders with a passion for people and manufacturing. Today and every episode, we are diving deep into the advancements, sustainable practices, and dynamic changes transforming how we produce everything.
And now welcome Alexandria Burek and A.W. Schultz.
Okay, welcome to another episode of Factory of the Future. And we have a special guest today, Richard Halsall. And like anything with Factory of the Future, one of the things we always like to bring forward is what's new in technology, what's coming down the pipeline within the manufacturing communities. How is leadership driving some of these changes? But in addition to it is also the sustainability part about it. And what we're going to be talking about today is something that Richard, the inventor and the CEO of Excel Fans, is going to talk us through on his journey on. He has created a fan, a bladeless fan that offers an energy-saving technology that's paving the way about how we see sailing fans in the future. So if you can, Richard, if you take Alexandria through kind of where the genesis of this idea came and some of the research that came into really becoming an inventor, because I think the audience would be interested in hearing about your journey.
Absolutely, A.W. And all the origin of this and the origin of most inventions is observation and asking the pertinent question. Can this be improved by doing that? And the critical nature of it, really it was myself and my former partner who came up with the banter originally that led to this, predicated on an observation of Nikola Tesla's turbine engine. The attempts have been made to turn that into a fan previously. However, none of it was successful. What was recognized by me was the input aperture was much too small. And by opening it up, you could actually reduce the RPM and still have airflow that would be in the nature of circulating an entire room of 25 by 25 foot, and everything in there would stabilize and be comfortable. And what I mean by that is the vertical column would be destratified, which was really the point of the entire development, was how do you circulate air efficiently and uniformly in a three-dimensional space. Prior technology was only two-dimensional. So that's kind of what brought us to the product being prototyped at that point. And of course, there's 4 or 5 iterations of prototyping before you get to something where you say, eureka. In my previous life, I was an airline pilot, and, you just, by being in that environment, airflow is everything. It creates lift. Laminar flow is always the goal of an aircraft. So smooth airflow, consistent airflow is also elements of experience that led to it. And in other words, it wasn't just a priori. There was empirical knowledge that went along to get the product to a point where actually manufacturing could take place.
You know, what's interesting, now you're explaining it to me, you remind me of the James Dyson and his invention of the vacuum cleaner and his airflow. I had read his bibliography, and he was just obsessed and made like 1,000 protocols on it. So I imagine that was kind of you might be humbly saying you waited for a few prototypes, but it probably was not something that happened overnight.
No, it certainly doesn't. Then the pursuit, you're absolutely right, A.W., and then you have to pursue perfecting the product as well, because philosophically, I want the customer to get what they pay for. And that is, why go in business if you're not going to do that? Because it's not a short-term viewpoint that I wish to undertake at this point.
So, Richard, when we were talking before we got on, you shared a pretty inspiring story, I thought anyway, about some of the customers' feedback talking about this, evolution of the product and getting it to this place where it seems to be not only good for the environment in terms of its reduced, electricity requirements and high efficiency, but also in kind of the health benefits to people. So I think it's important that we all, we've got one body to house as far as technology is concerned today. And so we should take care of our body. So what have you found with your fan and how it improves, it has a different effect on health than a standard traditional fan would. So can you walk us through that?
Certainly. Let's look first where we live in three-dimensional space. And all the items previous to keep us comfortable have been two-dimensional. A blower on a HVAC system is linear. It just blows in a straight line. Those who are in front of it are uncomfortable, and the ones who are not in front of the blowing air are also uncomfortable because they're not benefiting directly from the HVAC air. So this is a three-dimensional solution to that two-dimensional history. Mm-hmm. And in doing so, you're lifting the colder air, which resides at the floor, and you're lifting it and circulating it 360 degrees through the room. But what else are you doing by that function and that mechanical function? You're also circulating and diluting any particulate matter that also resides in the lower aspects of a room. We cough, we sneeze. Technically, it's called a viral plume. So by lifting it, there's a process of dilution that occurs to whatever viral or pollutants are in that area. So there's an increase to indoor air quality. Also, there's stabilization of temperature throughout the room. And thirdly, there's a reduction in humidity in the upper levels of the room as well. So the things like the propagation of mold and mildew spores, are also met with circulating air and a drying of the region. You need moisture for mildew to take a hold or mold to take a hold. And very similar to morning fog. If it's windy, fog isn't going to form. So we're passing air over all those surfaces simultaneously. Purdue University did two studies for us that proved out that the fan, for lack of a better description, that the fan actually does do what we say it does and also saves significant energy. The test they did said you can raise the thermostat 4 degrees Fahrenheit and still maintain the ASHRAE comfort standard of 72 degrees.
Wow.
And additionally, along that point, you can save per degree, and they did it for schools and hotels and large office buildings. So the aggregate of the savings I'm still comfortable to that standard, and and I can increase the thermostat between the Department of Energy and Purdue University is about 22%.
Wow.
Energy savings. So it's significant. And getting to the customer that contacted me, he was very gracious during the time of our call. And he has two daughters that live in a single bedroom, that sleep in a single bedroom with bunk beds. So he had a bladed fan in there, and he was very uncomfortable for the injury, the prospect of that may get injured. But they were also with direct air blowing on them. As a matter of fact, Neil deGrasse Tyson has a short video on the ill effects of air from a bladed fan blowing directly on you, drying your eyes, clogging your nasal passage, and ours doesn't do that. His call indicated to me, and what we talked about was his daughters wake up in the morning, their eyes are no longer dried out, their lips aren't chapped, they're not nasal, they don't have a lot of nasal congestion as they did, with the bladed fan. And that, he said, everything you say you do, it works that way. It does. And, for him to take the time and pick up the phone and give me a call, I thought that was great.
I feel like that makes it all worth it. And, as one of the things that didn't cross my mind as we were preparing here to get on the show was you're talking about that viral plume, and immediately my mind went to hospitals. Are you working with hospitals to get your fan in place in these places where obviously there's additional excess of contaminants and things like that?
We're trying, yes.
Okay.
And my biggest problem is I've devoted the preponderance of my time from when we started this to just recently perfecting the product, working in that, and not working in marketing or even getting in touch with people about it. But now we're in that phase. The product is magnificent. Its performance is great. So we're ready to go to hospital. I'm being a veteran. I'm trying to get into the VA hospitals. To be a start. Yeah,
that's amazing. Well, hopefully there's some people today listening or know somebody who's an administrative at a hospital and they can get you in.
Absolutely. It is my hope that someone will be able to reach out from this particular podcast.
So can we step into manufacturing? We'll change gears now that the audience has a great idea of who you are, what the fan does, the benefits, and how it's helping people and also companies reduce their electricity consumption. Can you take us through kind of your strategy on manufacturing? So you talked a little bit about the several iterations and kind of getting that to a point where you're feeling like the product is in its best state to date, right? So what would you say about like your manufacturing strategy? I think AW shared that you don't have your own particular manufacturing line, you outsource that. I'm just wondering what you can share as you were going through that process as well. And if maybe somebody else is an inventor and kind of at that stage of like, okay, we've prototyped it, but now where do we go to get this thing actually made? And how do we get to market quick? Because I would have to think that the selecting an outsource option was faster to market and probably driving a little bit of that decision. But I'd love to hear your thoughts.
an excellent, excellent not only question but excellent in a process, because obviously it didn't run as nothing ever seems to run as smoothly as we hope or envision. So in the United States, purchasing small efficient motors it's not available. The manufacturing plants aren't here. We elected to go with brushless DC motors that have permanent magnets in them. And that's all over in Asia. Taiwan is where we went. They were kind of the headquarters for products like ours. We weren't able to interest many large corporations to deal with us. I think they, not being born a DuPont, unfortunately, we were just working diligently to get people interested in building the product for us. The tooling went through a couple of iterations. Our decision was to go to Chicago Tool and Die to engineer the tooling, which, what the money that you spend on that is well worth it, because you get the best design for what you're trying to build. Shopping for a suitable partner, for lack of a better term, in manufacturing, it is best on your search and due diligence to make sure they know what quality means. In other words, they're used to working with Europeans or Americans, and they have a product line that is certified, and they follow all the standards to do it. So that's step one. Their capabilities have to be in line with your desire. Now, if you're making ashtrays, I don't think it's it's a pursuit. But anything of a technical nature, it's better to go with people who are used to that pursuit of high quality.
Yeah.
And we did. That's exactly what we followed. And there was a few iterations and a few changes had to be made. But if you refuse to accept less than perfect, you wind up getting them.
Yeah, exactly. That's a brilliant, AW and I were recently talking about, we're doing a series basically going back from the 1950s, talking about how each decade of manufacturing, what was going on, what was driving the changes, etc. And one of the things that really started in the 70s and 80s was this idea of advanced manufacturing, remaining American, where other types of manufacturing were offshored. So it sounds very in line with what you're experiencing, your trials and tribulations to get this thing brought to life. You experience, right? Having the tooling manufactured and engineered here, and then elsewhere produced, and of that standard, that advanced manufacturing standard. So very interesting stuff, Richard. Thank you so much for sharing that. AW, what are your thoughts here?
I was really interested into it, and what grasped me is that, and it's not so uncommon, where the story is it's engineered in the U.S. and it's manufactured in another place. What's interesting to me is it's how often this is the commonplace into it, that parts may be produced here but shipped somewhere else and shipped back and then assembled, and not necessarily in this case, but there's so many facets that drive the manufacturing communities, and to me, honestly, this is kind of one of my first exposures to firstly fans, but also an inventor that took something from ground level and is now out there on the roof or on the ceiling, to say it that way. But Richard, is there anything else you'd like to bring forward that you think our audience might be interested in?
Just the mere fact that energy prices aren't going to come down, no matter what anybody says. They're not going to budge, and the planet's getting hotter. These are factual items. So where are we going to? We still want to stay comfortable, and we spend a lot of time indoors. 60 to 70% of our expense is on HVAC. So this is a path to not only stay comfortable, but have the indoor air quality improve to where it doesn't become a sick place. And on top of it, you have an opportunity to save money as well. So science is the most wonderful thing in the world. And nature always points the right way of doing things, because nature is flawless. And I think as I went through this evolution to get here today, observations of nature and the use of science and mathematics and flow technology, it just air's a fluid. So in that aspect, it's just, for me, it's just a quest that never ever stops. And look, I'm 76 and I still love to do all of that.
Yeah.
And what a beautiful inspirational story too, to have had a whole separate career as a pilot and then literally changed gears into this inventor chapter of your life. And I think it's, I always say it's never too late. You're not too old and it's not too late. So thank you for being an inspiration in that way. And we're wishing you the absolute best. If there's anything we can do, we'll certainly do our best to help you and make connections where they make sense. And otherwise, Richard, thank you for being on the podcast today. This was fantastic.
Well, and reciprocal. Thank you for inviting me and hosting this. And it's wonderful talking to the two of you, and wonderful to have the opportunity. Thank you.
And
Thank you.
We'll have a link in the show notes if anyone wants to find out more about Richard and his Bladeless fan. But we're checking out here. This is Factory of the Future, and we are out of here like finished goods. Stay tuned for our next episode of Factory of the Future, where we're exploring groundbreaking techniques and behaviors that are reshaping industrial landscapes. Don't forget to subscribe and leave us a review and help others discover the cutting-edge insights transforming manufacturing as we know it.